Hey everyone, so we are moving on to another probability lesson. Today we're going to focus on experimental versus theoretical. So let's do a quick review of yesterday, pause the video and do these three problems. So a dice cube has 6 sides that are numbered 1 to 6. The cube is thrown once. What is the probability of rolling an odd? So remember, it's what we want divided by the total. So total possibilities is 6. An odd number is what we want. How many odd numbers are on the die? 3. So that's a half. If one letter is chosen at random from the word refuse, what is the probability that the letter chosen will be E? So my total, how many letters are in the word? 1, 2, 3, 4, 5, 6. And then how many E's are there? There are 2 E's, so 2 out of 6, which is 1/3. A bag contains 4 red marbles, 16 yellow marbles, 5 purple, 16 blue, 10 green. What is the probability of pulling out a red or a green? So in this one, our total is 4 plus 16 plus 5 plus 16 plus 10. So let's see what that is. That's 20 plus 21 plus 10, which is 51. So that's our total. And then red or green, what we want, I never finish like red or green. So red is, where's red? Red is 4. And green, where's green, is 10. So our probability is 14 out of 51. And that's our answer. All right, so the difference between theoretical and experimental. Theoretical is what would in like a perfect world, what would happen? So if you have a coin, if you flip it 10 times, you should get 5 heads and 5 tails. That's the theoretical what should happen. Right? So the probability of heads should be 5 out of 10, and the probability of tails should be 5 out of 10. But that's not always what happens. Experimental is using data that we collected to find probability. So in this case, I flipped the coin, I got heads 4 and tails 6. So the probability that I got heads was 4 out of 10. The probability that I got tails was 6 out of 10. So you need to pay attention to, is it asking about the theoretical or the experimental if they're doing an experiment? All right, so pause the video. I honestly think you guys can all do all of these. These are not that hard. What is the theoretical probability that the coin will land on tails? Well, like we said, that's 1/2. What is the probability of it landing on heads? Again, 1 choice out of 2. All right, so now we're getting a little harder. If the coin is flipped 140 times, how many times would you predict the coin lands on heads? Well, if heads is 1/2 times 140 flips, we should get 70. So that's a really common question where they want you to kind of predict. Johnny flipped a coin 450 times. His results are below. What is the experimental probability that the coin lands on heads? Well, he got heads 240 times out of 450. Can I simplify that? I can divide by 3. So that's 24 out of 45. Divide by 3 gives me 8 out of 15. And that's my answer. All right. So now same idea, but this time we're doing rolling a die. All right, so pause the video and try this one on your own. Okay, unpause. I want you to draw me a tiny little house. I think I did that one already, but we'll do it again. A tiny little house. All right, if it's 6-sided, we know the bottom is always going to be a 6 for all of these. All right, probability of rolling a 4. How many 4s are there? There is 1 4 on a die. 3 or 5. That's a total of 2, which is a third. Not a 2. Well, how many numbers are not a 2? 1, 3, 4, 5, 6. 5 out of 6 of them. You also could do the total minus 1. Same idea. Odd, 1, 3, and 5 again, that's half. If you rolled 300 times, how many would you predict a roll of a 1 or a 6? So a 1 or a 6, that's 2 out of 6, or 1/3, times how many times are we rolling the die? 300. So we would expect 100. So for experimental probability, we know the total was 1,500. What we wanted to happen was for it to land on a 4, and we got 280. And I'm going to simplify that. I'm going to divide by 2. I get 14 over 75. And again, if you want to put that in the calculator, turn it into a percentage, you can. All right, pause the video, try it on your own. So now for our total amount, right, we have a 4, and they're even, right? They're all the same. So 4. So how many are black? 1 out of 4. One region. You know what? I'm going to color code it to make myself happy. I got black. Oh, I don't have blue, orange, and I'll do red since I don't have purple. Here, we'll do that. All right. Not orange. How many are not orange? Well, 3 out of 4 of them. Probability of blue or black. Well, there's 2 regions out of 4. Remember, we add 1 plus 1. If the spinner is spun 40 times, how many times would you predict a spin of something that is not purple? Well, not purple would be 3 out of 4. So 3 out of 4 times the total number of spins gives me 30. So we would expect 30 rolls to be black, blue, or orange. All right, now we're going to do the experimental. So this is not theoretical. This is based on what actually happened. What is the experimental probability of spinning an orange? So orange was 21 out of a total of 60 times, right? It gave me 60. Oops. And then again, I can simplify, divide by 3. We get 7 out of 20. And then finally, which color has an experimental probability that matched its theoretical probability? All right, so out of 60, what's the probability of each of them? Whoops, my pen turned off. So if we were to roll 60 times, how many would we expect each of these to be? So it would be 1/4 times 60 equals 15. I should have written that down here. So what we expect 1/4 times the total number. So which one did we actually roll 15 times? Blue. Right? And that is it. We only have 2 lessons left, guys. Or 1. I can't even remember. I got to look into it. 1 or 2 lessons. We're almost there. All right, have a great day. I will see you guys tomorrow during our Google Meet. Bye.